This is Chris, and we are taking a look at questions 37 and 38 here as we wrap up the last section here in SAT Practice Test 3. So questions 37 and 38 refer to the following information. If shoppers enter a store at an average rate of R shoppers per minute, and each stays in the store for an average time of T minutes, the average number of shoppers in the store, N, can be calculated by the formula seen here. This relationship is known as Little's Law. The owner of the Good Deal store estimates that during business hours, an average of 3 shoppers per minute enter the store, and that each of them stays an average of 15 minutes. The store owner uses Little's Law to estimate that there are 45 shoppers in the store at any time. All right, so that's the general information that's going to apply to both of these questions. Now let's take a look at 37. It says Little's Law can be applied to any part of the store, such as a particular department or the checkout lines. The store owner determines that during business hours, approximately 84 shoppers per hour. And let's see if I can underline that a little bit more clearly for everyone. It's 84 shoppers per hour make a purchase, and each of these shoppers spends an average of 5 minutes in the checkout line. At any time during business hours, how many shoppers on average are waiting in the checkout line? So we're going to use this formula given above, and I'll rewrite it down here just so it's easy for us to reference. So we're going to use, actually they use a capital T, so I'll use one too. We're going to use N equals RT for this. And you might think, well, they give us 2 of the values here, and they're asking for the missing value. They give us the formula. That seems a little bit too easy for question 37. And you'd be right in thinking that, because question 37 is supposed to be a tough one. And so what's really important for us to appreciate is where the SAT is going to throw in some subtle tricks to try to make things a little bit more complicated. And if we know how hard a question is supposed to be, then a lot of times we're going to be better prepared and more on our toes at the right times. Here, they give us this unit for 84 shoppers per hour, and in the actual description of all the units for the equation, it's shoppers per minute. It's T minutes. Everything is in terms of minutes. So we have to do a conversion here before we can just go blindly plugging into this equation. And that's what makes this one a little bit tougher. So let's see if we can convert the shoppers per hour into shoppers per minute. So if it's 84 per hour, then if we break up that hour over 60 minutes, that would be 84 divided by 60 in order for us to get the number of shoppers per minute. And that comes out to 1.4. So 1.4 is the value that we would need to plug in for R, not 84. And now we can just go ahead and plug into the equation. So to solve for N, we get N equals 1.4 times the average time of 5 minutes. And that's going to give us an average of 7 shoppers in the checkout line during business hours at any given time. So that's a really important conversion for us to note and for us to make here on question 37. And I'll point out one other thing, and that's SAT is very nice. I like to point out where the test is actually kind to us. So they're, at College Board, they put together a clever reasoning test, but it's not all evil and malicious in terms of their intent. A lot of times they just want to test takers' ability to, pay attention, notice some of the details. But they will, as a nice thing, they will make answer choices realistic. So even if you did 84 here, and you did 84 times 5 because you didn't do the conversion, and you came up with 420, if you think about the number of shoppers in a checkout line at a store, would 7 be more realistic, or would 420 be more realistic? And you can very commonly use the realistic nature of the numbers that SAT will provide us with to sometimes catch a mistake like that. So if you came up with 420, you might pause for a brief moment and say, hey, you know what? 420 shoppers in line sounds like an awful lot. I think if I walked into a store, saw over 400 people in line, I might go ahead and turn around and leave. That might be, maybe one day a year during the peak of, Black Friday shopping or something like that. But as, a realistic number to expect, sometimes you can use that realistic nature of the values to maybe catch a mistake. So if you hadn't caught the conversion on number 37 earlier, then hopefully if you did the calculation, the sheer magnitude of the number you got might help you take a second look. All right, let's take a look at number 38. So for this one, it says the owner of the Good Deals store opens a new store across town. For the new store, the owner estimates that during business hours, an average of 90 shoppers per hour enter the store. And so again, we're looking at per hour here, and each of them stays an average of 12 minutes. It says the average number of shoppers in the new store at any time is what percent less than the average number of shoppers in the original store at any time. So for the original store, let's check our information, but I think they gave that to us, so let's see. For the original store, yep, that's going to be down here at the bottom. They said that for the original store, they had 45 shoppers at any time. So we want to see how this number is going to relate to 45. So now we have to calculate this number, and again, we have to do a conversion. That's 90 shoppers per hour, and we're going to do a very similar conversion to what we did over here. So 90 shoppers per hour broken up into 60 individual minutes, 90 divided by 60, that's going to come out to 1.5. So there's really 1.5 shoppers per minute entering the store. And we're going to use the same formula, n equals RT. So that would be 1.5 shoppers per minute times, let's see that value that they gave us here, 12 minutes. Okay, so that's how long they're staying in the store, and when we multiply that out, we get a total of 18 shoppers in the store at a given time, and they want to know percentage-wise what that indicates as it relates to this 45 shopper number for the original store. So here we're looking at a percent change calculation, which is going to be for this we have 45 minus 18, so that would be 27. So there's going to be a difference of 27. So that's what that decrease was. It was a decrease of 27, and as a percentage, it's a decrease of 27. Let me erase that circle so you don't think it's a final answer, but it's a decrease of 27 out of our original store value of 45. And then this will be a decimal, but if we multiply times 100, that'll convert it to a percent. And when we do the math on that, 9 goes into both of those, so you can certainly use calculator, but you can also reduce this. That's 3/5 times 100. It's going to come out to 60%. And that will be our correct answer here for question 38. And that goes ahead and completes practice test 3 for us. So hopefully you have had a chance to review everything you needed.